Okay. So last time we started talking about the total probability, and you said that in order to calculate the probability of an event over a certain random experiment, where the sample space is partitioned by different sub-events or events B1, B2, B3, and so on, such that all these events are disjoint and mutually exclusive. There is no common factor between them. In this case, the probability of A will be the probability of the summation of the probability of A intersect every one of these B1, B2, and so on. And we went through the proof. Why is this the case? Now, from here, we can see that we can go into this by finding that the probability of the intersect of A and Bn is the probability of A given Bn multiplied by the probability of B. Okay. We already talked about the conditional probability. Conditional probability was probability of A given Bn was equal to the probability of the intersection divided by the probability. So basically applying it here, this will be the product of this. Okay. And then we went, we stopped here. So basically, before that, we talked about the joint probability, conditional probability. So what we do today is we talk about the base rule, which basically is a step of the conditional probability. Basically, you can solve many problems using the base rule, and then we'll start talking about the independent events and the combined. Okay. So base rule. Base rule is a simple way of manipulating the concept of conditional probability. Consider that we start from the conditional probability. So the conditional probability of Bn, specific event, Bn given A is equal to the probability of the intersection between Bn and A, divided by the probability. And we said that we can understand this by either by this rule or by considering that given A, it's a condition, which means that there is a new sample space. And because there is a new sample space, which is A, then basically you need to divide by as we discussed last time. Now, on the same thing, equivalently, you can write, so this is one way to write it, probability of Bn given A, or you can write probability of A given N. Another problem, where now the condition that Bn has happened, and we are interested in finding the probability of A. In this case, it's the same. It's the probability, this is equal to the probability of A intersect Bn divided by the probability of A. So you can see that there are the same common factor in the numerator, right? So you can equate these two. By equating the common factor, you can find that this multiplied together equals this multiplied together. Because this is the rate is the common factor between them, and hence this gives you the probability of Bn given A multiplied by the probability of A equals the probability of A given Bn multiplied by the probability. So if I am interested in finding the probability of Bn given A, let's see before that. Like I don't have the probability of Bn intersect A. I'm not interested in it. I don't have it as information. However, I have another piece of information. I have the probability of A given Bn, and I have probability of Bn. Then I can solve this using. This is what we call base rule. As simple as that. So this is base. Okay. Now, in many cases, as we will see in the next example, BA here can be found using the total probability. Rule that we have done before, which is the probability of BA. Probability of A, sorry, would be the probability of A given B1 multiplied by probability of B1, blah, blah, blah. Using the total probability law that we have already discussed.
So how is B intersecting with Bn is the same as A given Bn multiplied by Bn.
How is what again?
B
The probability of Bn intersect A?
is the same as.
That's not the same. This is the same as this. Okay, now we have this said already in the set theorem that تتذكره intersect Bn intersect A is the same as A intersect Bn. And we said that we give you the properties of set theory. We said that if you exchange the order, it doesn't matter. Same thing in the meaning, right? So because of this, we have these two red things are the same. So if they are equal, this is equal what? Just multiplied by BA, probability of BA. Will be probability of Bn given A multiplied by probability of BA. This is equal to the red, right? And the same thing, probability of Bn multiplied by probability of A given Bn equal to the red. So these two things are equal. Just put them together in mind. What? So probability of probability of Bn, probability of Bn given A multiplied by probability of A equal probability of A given Bn multiplied. We just divided by B. It will be clear in a minute when we take the example. So let's have an example. This is an example of time basis rule is very important because you will find many cases. So please pay attention and make sure that you master it. This is what we call the binary symmetric channel. It's a well-known channel in electricity. And you don't need to be concerned about the communication part. What you need to be concerned about is how this channel works from a probability point of view. This has input. The channel has input B1 or B2. The input can be B1, ممكن يكون 0. B1 is 0, ممكن يكون B2 is 1. So basically the input to the channel either because it's 0 or 2. Okay. Now we call it B1 or B2. You think about it as bits, 0. Now the probability that you get a 0 or B1 at the end of the channel is 0.6. So 60% of the time you get 0. While the probability that you get B2 is 40%. And this goes through the channel. The channel ايش تسوي؟ Channel takes 0 as A1 as 0 90% of the time. So this is what? This is the probability that I receive A1 given that I send B. So this is the probability of A1 given B1. This is equal to 90%. Means that I don't make error. I send the 0 as 0. How much time? What is the percentage of that? 90%. And this 90% is equal to the probability that I receive A1 given I sent B1. Okay? So this is the output of the channel. Now, 10% of the time you send B1, however you make an error. You receive it as 1. 10% of the time, if you send 0, you receive it as 1. So the probability of A2, receiving A2, given that you sent B1 equals 1. Okay. Similarly, if I send B2, there is a probability that I get A2, which is 1. If I send 1, I get 1. 1. Okay. And there is a probability that I make error. That I send 1, I receive it as 0. The probability of correct reception, so the probability of receiving A2 as B2, given B2 was sent, is 0.9. While the probability of error, which is the probability of receiving A1, given that I sent B2, is 10%. الآن, we are interested in finding different probabilities. So what do we have here? We have a priori probabilities, هذه نسميها a priori. a priori probabilities. ايش يعني a priori probabilities؟ What does a priori means? Means that before I think over it, before I operate this, a priori. And we have the conditional probability or the crossover probability, or call it the conditional. We have the conditional or the crossover probabilities. If I send B1, what is the probability that I get A1? If I send B1, what is the probability that I get A2? Okay, crossover probabilities في بعض الكتب تسميها for conditional probabilities, crossover probabilities. تمام? And I'm interested in general in finding the probabilities of the output, which are called a posteriori probabilities. Posteriori probabilities. ما فيها بس الابوستولي means after. Okay? After operating the system. So I have the upper probability, which are the probability of B1 equal 0.6, probability of B2 0.4. I have the conditional or transition or crossover probabilities, which are the probability of A1 given B1. Which are the probability that given what I have seen, I now am the receiver and I didn't know what I have seen. As a receiver, I only see what I receive. So I receive a 0. As a receiver, I am interested in fine. Given that I received 0, what is the probability that what was really sent 0? Don't rush. Don't rush. هي الفكرة I received 0 and أبغى أعرف is it high probability that I transmitted 0 بمعنى إني what I received was correct, or I received 0 and there is a high probability that what I received, what I sent really was 1 and I make an error. So I'm interested in finding whether what I did as the receiver, الريسيفر سوى شيء received this as 0. طيب is 0 correct? Is this what I sent? And the purpose of communication is to communicate a message from transmitter to receiver. If I am able to communicate this message as accurately as possible, means that I did good job. And we need to measure how accurately we did this in this trend. واضحة الفكرة? Anyone has a question? So I'm interested in finding the probability of receiving B1, receiving 0, given that I send 0. I'm interested in finding the probability that, given that I received 0, what was the probability that I sent 0? So the probability of A1 given, so the probability of B1 given that I received 0. And also, what was the probability that I received, what was sent was 1, 0, given that I received 1, which is the probability of B2 given A1, and so on. If I receive 1, what was the probability that I sent 1, which means the correct message? Okay, which was a probability of A2, B2 given B1 given A2 and probability of B2 given A2. هذا اللي احنا نسميه فيها. واضح ليش؟ Any questions about? This is very important. This is an exam question. يعني تخيل فيه major one and question. Start for the exam. Understand. Base rule is very important, and this is a very direct application of base rule. واضح الفكرة الآن? What we have, again, I will repeat for the last time. We have an input, a distribution. I am generating zeros with certain probability, which is called probability of B1, and ones with the probability of B2. And I'm sending over the channel, and B1 goes as A1, or 0 goes as 0, with the probability of A1 given B1 of 0.9, and it goes as error with the probability of 0.1. or which is the probability of A2 given B1, and vice versa. Yeah? And I'm interested in finding the probabilities of, given that I received A1, what was the probability of B1? Given I received A1, what was the probability of B1? Or given I received A1, what was the probability that I sent B2? And same here. Given that I received A2, what was the probability that I sent B1 and B2? We are interested in finding this probability. أي سؤال for this time? أي سؤال? Let's see. طيب. So the solution is based on what we call Bayes rule. فتذكر Bayes rule هذا. This is the a priori probability. And this is the transition probability of the curve or crossover. And this is given. What we don't have is this and this. The probability that, given that I received 0, the probability of sending 0, that what I sent was 0, is found by using applying Bayes rule, which is the probability of A1 given B1 multiplied by the probability of B1 divided by 1. Now, what is the probability of A1? What is the probability of A1? What is the probability of getting A1? Do you have it? We have the probability of A1 given B1. We have the probability of A2 given B2 or given B1. But we don't have the probability of A1. So what we need to do is apply the total probability law. Probability of A1. When does A1 happen? You ask yourself only this. When does A1 happen? That's right. When do I get A1 here? From this symmetric trend. If I send B1, or if I send B2, huh? So A1 cannot happen either I send B1 and I receive it correctly, or I send B2 and I receive it wrongly. So basically the probability of A1 equals the probability of A1 given B1. So the probability that I received A1 given that I sent B1 multiplied by the probability of B1. Plus the other alternative, الاحتمال الثاني اللي هو I received A1 given I sent B2 multiplied by the probability that I sent B2. This is what? This is probability of A1 intersect B1, right? Plus probability of A1 what يا شباب? Intersect B2. And this is what we call the total probability law. This ضربنا هنا because this is the total probability law says that the probability of A1 is the summation of the intersection of the probability of the intersection between A1 with B1 and B2. هي البارتيشن. تتذكر في total probability law. I am interested in finding the probability of an event. Then I simply find A as the union of the event intersect with B1, B2, and so on. Here we have two B's, B1 and B2. واضح؟ فضربنا because this is the probability of the intersection. This is the probability of the intersection between A1 and B1, and using the conditional probability, it's equal to the conditional probability multiplied by the probability of B1. واضح يا شباب؟ I feel everybody does. Either I'm doing very fast or I just stop.
probability of the transition
وين هنا؟
عشان نطلع
تجمع ايه؟
الترانزيشن اللي هو 1 B1 زائد 1 B2
بس كده بدون ما تضرب؟
بدون ما واقسم على الستارت بتاعه.
Why did you do that? Is it this ولا ايه؟
ما هو اللي هيكون يعني البروبلم هو يا إنها هتكون B1 صح يا إنها هتكون B2 0.
طيب كلامك صح. However, this is very interesting. زميلكم يقول okay. In order to find the value of A1 هتيجي من وين؟ يا B1 يا B2 صح ولا لا؟ So I only sum this with this. However, this happens how many times? What is the fraction of this happen? Exactly. This can happen only 60%. And this can happen the remaining 40%. تخيل انه this happens بدل 0.6 خلينا نقول 0.9. So basically your source generates zeros 90% بينما ones 10%. ما تقدر تجمع هذه وهذه تقول انا طلعت البروبابيلتي لانه هذه تحصل هذه ويتد تحصل اكثر 90% تحصل من الوقت بينما هذه 10%. واضح؟ عشان كذا we need to weight every probability by the condition. واضح الفكرة؟ طيب good. Other questions بقى. So if you ask things become more clear. Okay, so basically this is why we did not add the conditional probabilities because every conditional probability has a probability that it could happen, which is the probability of generating zero or generating one. Okay, so طبعا just putting numbers. The probability of A1 given B1 is 0.9. Probability multiplied by probability of B1, which is 0.6. 0.9 multiplied by 0.6 plus the probability of A1 given B2, which is 0.1, multiplied by how much time, or what is the fraction of time the source generates B2, which is 0.4, and you get 0.5. So this means that 50% of the time you will find at the receiver 0, and 42% of the time you will find 1. Why 42? What is A2? Why 1 minus? هل عندكم احتمال ثالث هنا؟ At the output, do you have a third alternative possibility? Yeah, A1, yeah, A2. So because of that, because of the total probability equal 1, this is equal 1 minus probability of A1, which is 0.42. Because we only have 2 possibilities at the receiver. Okay? Total probability clear? Any question? So, طبعا. Yeah.
أنا يعني لما أخذنا على بالي بدأنا في الصورة وقت السكشن كان إيه؟ السكشن بالنسبة لهذا ما صار واضح إنه نستخدم تكنيك في طريقة يعني كيف أوضح يعني شو ده؟ بس
تقصد في الفين دياجرام يعني؟ Yeah, يعني you think about it this way, using Venn diagram. Using Venn diagram, you think about it as this way. This is the sample space, right? At the receiver, at the transmitter. At the transmitter, what do you have? You have 2 sets basically, B1 and B2. This happens 0.4, 0.6 of the time. This happens 0.4. صح? Now at the receiver, at the transmitter, at the receiver, what do you get? You can get only يعني خلينا نرسمها برسمة لون ثاني. The receiver you can get either A1 or A2. يعني الأخضر هو التقسيم the receiver. Now how can I find what is the probability of A1? What is the probability of A1? A1 has 2 parts. A1 intersects B1 and A1 intersects B2. So basically this is the probability of A1 intersects B1 plus the probability of A1 intersects B2. And then you apply using the conditional probability. So this is basically using Venn diagram. Similarly for the A2, A2 you can find it as probability of A2 هذه زائد هذه. Okay, it's probability of A2 intersect B1 plus probability of A2 intersect, sorry, B2. Okay. So basically, think about it as this. First of all, you need to find good enough to visualize using a Venn diagram, or you can think about it from here. That at the output, I only have two possible outcomes. And these possible outcomes, the first one is only possible when you have either coming from B1 or B2. What is the probability of B1? And how can I get B1 into A1 using this? Think about it that way. So,
yes. أنت تقول أن في 4%
58.
no 54 the chance
هذه قصدك؟
أقدر أقول إن النسبة إنه تصير B1 وإنه تصير A1 أنت شايف intersection يعني 0.9 comes to 0.6
هذه
yes.
هذه هي probability that you send B1 and you receive A1 and there's no condition here, which is هذه probability. هذه هي the probability of A1 and B1. So basically you send a B1 and you receive A1. بينما هذه probability of receiving A1 given that you send B1. Given أنا already sent B1. إيش probability إني I receive A1. هذه الثانية the probability that I send B1 and I get A1. واضح الفرق؟ Excellent. طيب other questions. تفضل.
لو كان عندنا شيء A1 given B1.
نعم.
اسمه عندنا شيء ثاني.
اللي هي A1 given B1 but
B1 given
oh you have this but you don't have this قصدك؟
نقدر نطبق نفس القانون.
لا this is a very good question. خليني أعطي لك إياها. الآن your friend is saying okay I have these probabilities هذول الثنتين but I don't have these. صح؟ ما حد أعطاك إياها. Good. الآن think about it this way. أنت you send B1. أنا أعطيتك قلت لك إنه if I send B1 given B1 I receive A1 with a probability of 0.9. So what I gave you is this. What I gave you is this probability of A1 given B1 equals 0.9. السؤال what is the probability of A2 given B1? Why 1 minus? لأنه هذا نفس الcondition. Once we fix the condition, it's the same sample space. Okay, so this is 1 minus 0.9. لأن ترى تلخبط في ناس يجي وأنا شفت الإكزامز في شباب كثير يلخبطوا الدنيا بعدين يقول لك أوكي أنا ليش أطرح هذه من هذه؟ أنا ليش ما أطرح هذه؟ ليش ما أطرح A1 given B2 equals probability of A1 sorry 1 minus في شباب كذا يسووه 1 minus probability of A1 given B2 sorry A2 given قصدت أنا A2 sorry A1 given B1 ايش رايكم هذا صح ولا خطأ؟ The condition is different, so it's different sample space, different problems. This is wrong. واضح يا شباب؟ اي طبعا اذا في A3 في another third outcome ما تقدر كذا تسويها بالسهوله هذه انك تطرح على طول. You cannot do it. You have to find the value of the second one بعدين بس واضحه هذه الفكره؟ هذه this is a very common mistake. Why? people think that okay, if I put B2, B1 في أي مكان أطلع نفسه. لا, هي ما تفكر كده. أنت you need to look at when you apply this total probability, you need to total probability 1 minus. You need to make sure that the same condition is there, and the condition changes the sample space. Okay. Great. Good questions. أسئلة حلوة. Other questions. طيب الآن if we would like, now we found the denominator. We found probability of A1. Now let's find probability of B1 given A1, which is the probability that, given that I noticed that I received 0, what was the probability that it was correct? Which is I said 0. Simply, we now apply in Bayes rule, which is probability of B1, B1 given A1. Probability that given that I received A1, what was the probability of I sent B1 is equal to this, and by Bayes rule, it's equal to this. We have all the parameters, numerator, and we found the denominator. So we just multiply and divide, and we get 0.93%. What does this mean? It means that if I receive 0, the probability that this 0 as a receiver represent a 0 as a transmitter, معناها صح. What I received is correct, is 93% of the time. Okay. So again, given that I received 0, the probability that I sent 0, what I sent was the same that what I received, is 93% of the time. It means that the probability of the other way around, which is now fixing the condition, Can we do this? Fixing the condition, can we do this? It was the same condition. Given A1, I asked my question. But then what was the probability that I sent B1? No, what is the probability that I sent B2 given A1? It's 1 minus what we just found. So it becomes 0.69, which is the probability of error, the condition probability, because it's given A1. So find for me very quickly the probability of B1 given A2. Quotation, try to find. So given that I received A2, what was the probability that I sent B1? معناها error. Any question? Any answer? Fourteen percent. 15.3? 14.3. So your friends are saying 14.3. Or 0.143. نفس الشيء تعود عليه. Any other answer? 58.7. No, B2. Oh, B2 given 58.7. هذه وضعنا في مشكلة الآن. One of you are.
sorry, 85.
85. Okay. نايس شباب. السلكم حل. 85.7. طيب ممتاز. ايش رايكم؟ They add up to 100. Anybody has another answer? طيب quickly. What is this? It's probability of A2 given B1 multiplied by probability of B1 divided by probability of A2. Do we have all of them already? Right. This is 0.1 multiplied by 0.6 divided by 0.42 exactly. And you end up with اليوم متأكد من الرقم ممتاز. Great. So 0.14 ممتاز. طيب other question before we leave this example. Now, so this is an example. However, I can give you the same using the tables. بتتذكر التيبلز هذه. الريزسترز الكلام هذا كله. I can give you the same answer, the same set of questions using the same table. ألخبطك شوية. Here مثلا we found the probability in the intersections, right? Now I can ask you, what is the probability of I getting 22% given that I noticed 5%? So you need to be comfortable applying Bayes rule. So try to play some examples here. Same thing for the previous example given. في example كده. Different example. هذا واحد ثاني. فتراي شباب playing with the Bayes rule. As I mentioned, it's very important concept. It's very simple, however very important, very powerful. طيب, now, any question before we move to the next section? So in this section, we'll talk about independent events and combined experiments. Okay, so we'll talk about independent events, combined experiments, and then we'll talk about some counting principles, permutation and combination, the Bernoulli trial, and some simplification of the combination. Okay, now very important concept is the independent events or independence. We talked so far about events, and we talked about mutually exclusive events, right? And we see that if we have two events that are mutually exclusive, means that there are no common elements between them. Huh? No common elements between them means that if A happens, B cannot happen. Okay, so the happening of B depends on whether A can happen or not. If A happens, B cannot happen. If B happens, A cannot happen. Right? This is what we call mutually exclusive events. Now there are different version or a different notion, which is the independent events. Independent events says the following: two events are independent. A and B are independent. We call them statistically independent. For short, in the future and in many places, we call them independent directly. If the probability of A given B equals the product of the individual probabilities. So probability of A given B, probability of A intersect B equals the probability of A multiplied by the probability. Okay, we'll give example. However, independent one, this is given that both of them are possible. So it means that the probabilities of A and the probabilities of B are not zero. Now, what does independent mean physically? Physically, independent means that if A happens, B may or may not happen. Basically, the happening of A does not alter, does not change whether B can happen or not. Does not change the statistics of B. Yeah, مثلا, if A happens, if B happens with a probability of 0.2, when A happens or not, the probability of B doesn't change. Still, ممكن يحصل 20%. So independent events means that the two events have no relationship between them. كانوا ايه علاقة ببعض؟ independent من الاسم. واضحة؟ It's different than mutually exclusive. Now, if I ask you, A and B are mutually exclusive.
Why do we say the probability of A shouldn't equal zero?
إلى نحن نيجي عليه. يكون في بعض الكوميونيكيشنز. Okay. الآن mutually exclusive events. Two events are mutually exclusive of this one. A can have, if A happens, ايش يصير في B؟ لا mutually exclusive. هل هذول independent؟ واضح انهم dependent لانه if A happens B cannot happen. B خلاص مصير مستحيل. So these are dependent events not independent. بينما ال independent events if A happens we can or may not happen. We don't know. ما له علاقة تماما ما له علاقة. واضحة؟ الآن as a consequence of this if A and B are independent from the understanding from the explanation that I just mentioned if A happens ايش يصير في B؟ nothing changes صح؟ So the probability of فهموها كذا ما تحفظها. The probability of B given A equals the probability of B. ما تغير شيء على B. Okay? بدون الماث just physically because they are independent if A happens the probability of B doesn't change. ما يتغير شيء على B. B continues to behave the same. Okay? So mathematically, you can write the probability of B given A equals the intersection probability divided by the probability of A. زي ما تعلمنا في condition. And given this rule, the independence, then the probability of the intersection equals the product. Now A cancels A and you end up with. This is mathematically. However, we need to understand the intuition behind it. Why is this happening? أي سؤال يا شباب؟ هنا؟ طيب يعني نحن we came up with a condition. Here أصلا everything is derived from here. Probability of B given A if independent. If independent, this is equal to the probability of B. هذا هو الأساس. This is the basis of the independence. And from here, we can write probability of A intersect B equals what? Probability of B given A, صح? Multiplied by probability of A. However, because of independence, this is equal to come. And hence we get basically the rule. So everything starts from the concept that the independent events have no relationship. The probability of B given A does not change with conditioning. If A happens, B ما تغير عليه شيء. We can use the same. واضحة كده؟ تفضل.
So A and B, they could have an overlay in the intersection.
Yes.
But they may be totally independent.
Yeah. I have example. So what about now الآن بما إنه عندنا A and B are independent, we get this rule and probability of B given A equals this. What about B with the complement of A? So A and B are independent. What about A and the complement of B? Sorry, what about B and the complement of A? Axel A. ايش رايكم؟ ايش رايكم physically؟ فكروا بالمنطق. Logic. If B and A are independent, ما لهم علاقة ببعض. طب what about B and the complement of A? Ax A. أصلاً ما لهم علاقة لأنه the A happens B doesn't change صح؟ طب if A doesn't happen هذا هو الكومبلمنت صح؟ complement of A means A doesn't happen. طب if A doesn't happen هيتغير شيء على B؟ دائما فكروا بالفيزيكس of the problem, not only the math. So طبعا هذا mathematical derivation. B equals B intersect S. However, S is A union A complement. And because of that, we can distribute the B, the intersection, على ال A with A complement. Okay? Now the probability of B, لو تلاحظوا هذا B intersect A, هذا B intersect A complement. They are ايش؟ disjoint صح؟ Then this is B intersect A, this B intersect the rest of the sample space. So they are disjoint, and because of that, the probability of B equals the probability of the first plus the probability of the second. واضحة؟ So the probability of B intersect A equals probability of B minus this. Right? We just interchange terms. However, they are independent. ايش يعني independent? Means that the probability of the intersection equals the product of the probability of A and B. Now we take common factor, probability of B, multiplied by the rest, which is 1 minus probability of A. However, what is 1 minus probability of A? It's the probability of the common. So if A and B are independent, then the probability of A intersect A complement equals the product of the two probabilities, which means that B and A complement are independent. تكلمنا عن شيء logic والphysics. Why? الآن we do it mathematics. You need to be good at both. Understand the physics and the logic. Why? And also you need to be able to manipulate the math and be comfortable with it. Okay? أي سؤال؟ Now let's talk about some talks about independence and an example. Independent, this basically what we call sufficient but not necessary. So if probability of A intersect B happens to be this, satisfying this, okay. It's sufficient but not necessary. So it could happen that the probability works out in numbers that this is satisfied. Like مش هتبقى. However, if they are independent, this must be satisfied. واضح الفكرة؟ مش يعني I can pick two numbers مثلا rolling the die. You can pick two events ما لهم علاقة ببعض. Two events this mutually disjoint وتطلع اثنينهم satisfying this. لكن مش هتبقى independent. However, if they are independent, they must satisfy this. هذا نسميه sufficient but not necessary. So if this is satisfied, مو معناه انه they are independent. However, if they are independent, this must be satisfied. واضحة الفكرة؟ طيب. طبعا independent simplifies many things in the natural life. And when we come to problems related to multiple random values, two random values or more, when we come later to random process, we will see that independence makes our life easy. And independence will come as something from naturally correct, only something that we are making it up. But then it's immediately electric circuits, communication systems. The noise comes from different parts of the circuits, in the transmitter or receiver, different chips, different parameters, different components. And there is no reason to believe that physically the noise is coming from this chip is correlated to the noise coming from that chip. No. This chip is designed maybe by Intel, the other chip might be designed by Apple. Basically, there's no reason to believe that the noise coming from different components, electric components, are related. And because of that, they are independent. And from this, will bring some more powerful results later. However, what I mean is that in independence, in many cases, in many engineering cases, you will find it as a valid assumption. Okay? Now, if probability of B is larger than 0, probability of A is larger than 0, then the probability of the intersection, if the probability of the intersection is 0, it's something I have to okay? However, if this probability of intersection is equal to the product, it's something ايش قلنا هنا؟ If they are mutually exclusive, can be independent? No, they are dependent. احنا عارفين مو نعرف مو انه we don't know. No, we know. Mutually exclusive means that if one happens, the other cannot happen. So they are dependent. إنهم علاقة ببعض. بينما independent, if one happens, can probably affect another. Okay. So for two events to be independent, this should not be 5. لازم يكون في common elements. We cannot have no common elements. Because if they are disjoint, then basically one excludes the other. واضح الفكرة؟ الآن let's have an example اللي هي الشد الكارز. 52 cards and you have كم قلنا كثير كمان شباب الخبراء يساعدون right half red half black okay and it's divided into 4 quarters كل واحد يحمل شعر قلب وشجر مش عارف ايش خلاص الان let's have the following questions. Event A is select a king. طب سيبني بالفيلم طيب, so I will just explain an example and then I will leave the solution next time and try to solve it yourself. Event A, select a king. Event B, select a jack or queen. Event C, select a heart. Now we will examine, but we will find the qualities of each one and so on as its size. However, after that we will examine which one of these are independent events. Let's write them. Which one of them is independent? A and B are independent. Can you select a king and at the same time? Sorry, can you if you select a king, هل ممكن you select a jack or a queen? واحد excluded هذا. What about the king will have? ممكن يكون king and heart. صحيح. طيب. Anyway, next time inshallah we'll continue. Thank you very much. اللي ما يحب attendance please send it. Thank you.